Right now, as you read this, there are roughly 10,000 planes in the sky, each one weighing between 40 and 400 tons, packed with humans, traveling at 900 kilometers per hour at 35,000 feet, and somehow, not falling. How? How does something the weight of 70 African elephants just float up there? The answer involves a concept called lift, a very old argument between physicists and one geometric shape that changed everything. Let's break it down, 5W1H style. WHAT. What is lift? Lift is the upward force that keeps an aircraft airborne. It acts perpendicular to the direction of motion, straight up fighting gravity. It's generated by the wings, and the secret is the shape. A wing isn't flat, it's curved, thicker at the front, tapering to a thin edge at the back. This shape is called an airfoil. When air hits the front of the wing, it splits. The air going over the top has a longer, curved path to travel. Faster air above, slower air below. Faster air creates lower pressure. The bottom pushes up harder than the top pushes down. That pressure difference, that's lift. WHY. And here's where it gets nerdy, in the best possible way. There are actually two explanations for why wings create lift, and physicists have argued about which one is correct for over 100 years. Theory 1. Bernoulli. The curved top makes air travel faster above the wing, which lowers pressure, which sucks the wing upward. Theory 2. Newton. The wing is angled slightly upward, called the angle of attack. It deflects air downward. Push air down, get pushed up. The true answer? Both, simultaneously. Bernoulli explains the pressure difference. Newton explains the deflection. Real lift is the result of both working together, which is exactly why modern aerodynamics took decades to get right. WHO. Who on earth figured out that these wings could do all that? The foundation was Daniel Bernoulli, a Swiss mathematician who published his fluid dynamics principles in 1738. He wasn't thinking about planes. There were no planes. He was just very curious about how fluids behave. George Cayley, a British engineer, applied these ideas to flight in the early 1800s. He was the first person to correctly identify lift, drag, and thrust as the three forces controlling flight. And then in 1903, two bicycle mechanics from Ohio named Wright decided theory was fine, but they wanted to actually fly. So they did. Orville Wright's first powered flight lasted 12 seconds. The aircraft traveled 37 meters. Today's Boeing 787 travels that in the first millisecond of takeoff. WHERE. Where exactly does lift happen? Primarily, the wings. The main wing generates about 85% of total lift. The leading edge has retractable slats that extend during takeoff to increase the wing's surface area and lift at low speeds. The trailing edge has flaps, large panels that drop downward on landing to slow the plane and maintain lift at lower speeds. At the wingtip, those upward curved fins are called winglets. They don't create lift. They reduce drag by stopping air from spiraling off the wingtip. Airbus winglets alone save 3 to 5% of fuel per flight. Lift is everywhere on this aircraft. UHEN. When does lift fail? Lift can fail when the angle of attack, the angle between the wing and the airflow, gets too steep. Beyond a critical point, the smooth airflow over the top of the wing breaks down completely. This is called an aerodynamic stall. The instinctive reaction, pull back on the stick, makes it worse. The correct response is to push the nose down, increase speed, and let the airflow reattach. Modern aircraft have stall warning systems that shake the stick well before reaching that critical angle. Ice on the wings can also disrupt the airfoil shape and kill lift. That orange de-icing liquid is absolutely not doing nothing. HOW. Let's bring it all together. Flight is the balance of four forces: lift, weight, thrust, and drag. On the runway, the engines produce thrust. As speed builds, air flows faster over the wings. The pressure difference grows. At a specific speed called the rotation speed, lift finally exceeds weight, and the wheels leave the ground. At cruise altitude, thrust equals drag and lift equals weight. The plane doesn't climb or descend, it just floats, perfectly balanced at 35,000 feet. Four forces, one shape, 120 years of engineering. That is how 400 tons stays in the sky. So the next time you're sitting in a window seat at 35,000 feet, remember, it's not magic. It's Bernoulli, Newton, Cayley, and two brothers from Ohio, all working together at 900 kilometers per hour. That's the full story of flight, broken down 5W1H style. If your brain is 3% more impressed by wings right now, hit subscribe. New topic, same formula, zero boring lectures. I'll see you in the next one.